Hello everyone, my name is Lata Kaushik and today we will be discussing feedback and feed-forward control. Feedback control and feed-forward control. So we will be discussing their definitions, their structure or organization, and we will also be discussing their advantages and disadvantages. Right? So first let us discuss feedback control. Feedback control is which gets an output from which gets an input from your output stream, right? So what is its structure? This is your system. There is an output. There is a feedback stream that goes as input to your feedback controller, which gives an input to your system, whereas your feedback controller is the one that is actually receiving your input, right? So your signal will be traveling like this. Your value will be seen by the first pass. It will go to the system. It will measure what the value is. It will go here. It will check if it will give the output, but it will still show the value of this output. This is your feedback. It will tell the output value to your feedback controller, and this will decide whether this is right or not, if we need to increase or if we need to decrease, or if we need to do something for that, and then it will give you another input for your system, right? Now what are the advantages of this system? First of all, because it is actually doing it after it has been sensed or after the output has been done, so whatever the cause of the disturbance, the corrective action is always taken as soon as the controlled variable is taken from the set, as soon as the control variable is different than your actual value, right? So regardless of the cause and nature of the disturbance, corrective action is always taken as soon as the control variable deviates from the set value or set point, right? So if this is the value that you have set, that you want 40 degrees Celsius, then as soon as your temperature reaches above 40, that control will start decreasing. When it has gone here, it will start when it reaches here, it is going down, it will start increasing. It will go here again, then again it will start decreasing, then again here, again increasing, then it will go here. So slowly it will get a static value. So this is what the advantage is, that as soon as the value changes from your set point, there will be a corrective action taken by the controller, right? Next, for a feedback control, any kind of mathematical model is not actually necessary, because we know if there is change, the controller will change the value if there is a change in value, right? So a mathematical model of the process is not needed or necessary for feedback control. But we know that if we have a mathematical model, it will be easier for the controller to see or change according to that. If it is a non-linear system, we can change according to the equation that we already have, right? The next one is, the most common feedback control is PID, which is your proportional integral and derivative control. Is durable and adaptable, because it, as we will discuss later, this will actually give you different this will give you different variables to control and have complete control, but still keep your value in your optimum points. Retuning of the controller, that is changing the values of constants in the system equation gives sufficient control, right? Okay, so now